All right, now let's head to the module 2. Before we actually get to that point, I would like to just go over one of the questions about the common logarithm. So like I said in the previous video clip, I said that when the base is 10, we can just get rid of it. We can make it invisible, and log of x is basically essentially the same thing as log base of 10 of x. So as you can see right here, log 100 means it's just going to be the same thing as log base 10 of 100. So when you put in a calculator, and if you're looking for the actual value, like estimated value of log base 10 of 100, then what you can do is just plug in log, which would mean log base of 10 and whatever the number is for the argument. We call this number in here argument. So log 100, that is what you need to put, all you have to put on your calculator when you are looking for log base of 10 of 100. So let's take a look at the calculator for a second. So you can solve that question without a calculator, but if you like to use calculator, which seems sometimes very easier way to do, is to find log 100. You can just click on log and then put 100 and then close parenthesis and hit enter or equals sign. Then it should give you the answer right away. So your answer is going to be 2 for number 17. Okay, so that's what I need you to do. Like I said, you can solve it without a calculator, and that's the way that you can again change this into the logarithmic form into exponential form. So the base is 10, and what you need to figure out here is the exponent, and that should give you 100. So 10 to the what power should give you 100, and that is 2 as well. So you can either use calculator, go for it, hit log and then 100 and close parenthesis. That should give you the answer right away. If you prefer not to use calculator for these easier questions, then you can just use the method that we have done using, like change it into the exponential form, 10 to the power equals to 1, and figure out what that exponent should be. Again, with the calculator, you would just hit log and then 1, which will give you the answer. So I need you to try with a calculator and without a calculator as well, and see if you get the same answer for both of the method. Okay, so now we're going to move on to module 2, which would contain 4 different properties of logarithms. So just like our exponential properties, exponential rule, they have power rule and product rule, quotient rule, and the last one is something that you haven't seen in exponential forms, exponents, but I think that rest are pretty similar, if you will. So I'm going to start off with a power rule. Actually, the power rule is not really similar to exponential form, but it's really easy one if you pay attention. So let's take a look at this. Log base b of x to the nth power. When you have the exponent in the log, then what you can do, what you can change, the way you can rewrite it is bring this n, this exponent, to all the way to the front, and this is multiplication. So it becomes n times log base b of x. Simple, right? When you have exponent, you can bring it all the way to the front and multiply to the logarithm. So, for example, if you got log base 4 of 7 to the third power, then what you can do with this exponent again is bring it to all the way to the front. Yeah. So then, okay, so apparently I made a mistake in this example. This is supposed to be not 4, but since we brought that 3 to the front, it has to be 3. All right, okay, so it has to be 3. 3 is supposed to be in the front. So 3, and then log base 4 of 7. All right. So let's try number 21 together. Expand log base 2 of 49 to the third power. Using this power rule, what we can do is changing this 3, bring this 3 to the front. So what we're going to do is put what in the front? Put 3 in the front, right? Put 3 in the front, and then log base 2 of 49. And that should be your answer. Not that difficult, right? Okay, so I need you to do the rest the same way. Just bring the exponent to all the way to the front, and that's going to be the power rule. Now then, the product rule is this is really similar to the exponent product rule. So when you are multiplying x and y for the argument, so then you can break it down into log base b of x plus log base b of y. So in the product rule of exponent, when you have b to the x times b to the y, you were supposed to change it into b to the x plus y. Just like that, when you are multiplying these arguments, what you can do is break it down into plus, but separately. So log base b of x and log base b of y, and make sure that it's plus in the middle. So here's the example. Example is log base 4 of 5 times x. Now 5x means that 5 times x. And since this multiplication is a product, so we are going to break it down into log base 4 of 5 plus log base 4 of x. Now, using the same rule, if I break down number 25, expand this using the product rule, then what I can do is log base 3 of something, and then product rule, so it's going to be plus in the middle, and then log base 3 of something. All right, so what should be that argument in here and here? The number goes here is going to be 7, and then the letter goes here is going to be a. So log base 3 of 7 plus log base of 3 of a. So what I need you to do is the same thing. You're going to break it down into log base, whatever that space is, and then in the middle, you're going to put plus, and then you're going to put another log. Now, if you move on to the next part of the log product rule, I would like to go over number 29, which could be a little bit more challenging one. So 16m to the second power is our argument. And when I break down, I need to break down 16m to the second power first. 16m to the second power is 16 times m to the second power, right? Okay, so first thing that I can do is break it down into log base 2 of 16 and log plus, again, the product rule is plus in the middle, and log base 2 of m to the second power. If you want to go a little more, then you can bring this 2 to the front as well. So final answer would be log 216 plus 2 log 2m.